Hi guys, today we'll be solving longest palindrome substring. So we are given a string and we have to return the longest palindromic substring present in the string given. So in this string BAB, AB, AD, we have BAB as one of the palindromic substrings. ABA is also a valid palindromic substring. In this CBBD, the palindromic substring is BB. Let's try and solve this question. So let's say we are given a string. So we can see that here there is this substring that is a valid substring, a palindromic substring, and maybe this is also a valid substring, and this is yet another palindromic substring. So this example is slightly different from the one that is given in the Leetcode. Let's change this so I can explain you some a little bit better. And this one here over here is also a valid palindromic substring. So how do we find out if a string is palindromic? So a palindrome is basically a string in which if you write a string and you reverse it, it'll still give you the same output. If I write from left to right, it'll be ABA. If I write from right to left, it'll still be ABA. So I guess you understand what is the palindrome. Now let's try and solve this. So what we could think of, the brute force approach would be to make all the possible substrings that would take time complexity of O of n square, and then check for if it's a palindrome or not. That would take a time complexity of O of n. Let's see what I'm trying to talk. So let's start from here. We see okay A, and then we'll try to make substrings that is possible with A. So first substring that would be is A and B, A, B, and then we'll check if it's a palindrome or not. So AB is not a palindrome because if we write AB and we write it from the other side, it will be BA, so it's not a palindrome. We'll move forward. ABA. Okay, this is the palindrome. ABA, ABA. This is a palindrome, and we'll keep palindrome count. I mean the length count. So it will be 3, and we can keep on doing it. So what I'm trying to say is that every time we are trying to make a string and then check for if it's a palindrome or not, it will take a time complexity of order of O of n cube. So this might not be the most efficient way to do it. There is yet another way that can reduce the time complexity by an order of n. So it will be effectively order of O of n square, in which we can possibly achieve this task. So what we could do is we can use another method to find out if a string is palindrome. Instead of checking it from both sides, we could do it by instead of checking it from outwards to inwards, we could check it from inwards to outwards. Let me try and explain. let's say we are at the position 1. So our pointer is here. Now we can check how many characters next to it can possibly form a palindrome. So there will be a left pointer and there will be a right pointer, and we are currently at this pointer. This is just an example. So this is a valid palindrome. B in itself, any character in itself is a valid palindrome. So if we move the right pointer rightwards and the left pointer leftwards, we see that left and right pointer both point to the same character, that is A. So B was a palindrome in itself. These two are the same. So this is also a palindrome. So we have found a valid palindrome. And we can keep on doing this for every single character in this string. So you see how just by changing the style of checking if a string is palindrome or not, we can save a lot of time complexity. So what we could do is, we could traverse the entire array once, and while traversing each time, we could check if it's a valid palindrome or not. So traversing it once would take a time complexity of order of O of n, and checking whether if the string is palindrome or not will take another time complexity big O of n. So for each n, we'll be approximating it to about the string of length would be n. So we'll say n into n, that will be n square. So the time complexity of this scenario would be O of n square. And because we are not using any additional arrays to store any string or anything, the space complexity will be O of 1. Because we are just using 2 or 3 pointers, so the space complexity is constant. So just by changing the way we check for a palindrome could make a huge difference. Let's try and look at the code now. So this is the C++ code. Let's try and run this. So it runs perfectly. What we are doing is, we have a string result which will return the palindrome, longest palindrome that we are trying to find, and there is only one for loop. So you can see that there is another loop within this. So as I said, for each iteration we are trying to find the possible palindromes that we can make. So some of the conditions here are, the left pointer should never go behind 0th index, and the right pointer should not go beyond the nth index. And then this condition should be always true, that left pointer should be equal to the right pointer. And then there is this edge case that we can discuss. In this case, you see that this is a even lengthed palindrome. So in such a case, what we could do is, instead of doing left pointer I and the right pointer also I, we could actually shift the left pointer and the right pointer to be adjacent to each other. The right pointer will be one right of the left pointer. So this way we could also take care of the even lengthed palindromes. So first we would check if it's an odd lengthed palindrome, and if it's a even lengthed palindrome, we'll check that also, and we'll see whichever has the maximum length, we would be eventually considering that as the longest palindrome. So I hope you liked this video. If you did like it, do share and subscribe.